evaporation? What do you remember?
Evaporation in the process when my solid state is fluid, it's gaseous state.
Liquid changes.
Sorry, liquid.
Solid changes to liquid and liquid changes to gaseous.
Evaporation. What
Liquid
is it?
changes to gaseous.
When does it change? Liquid is changing into gaseous state. When? Yes, that is important. What did you tell? When a solid is changing directly into gaseous state, is that part evaporation? What is it called?
Sublimation.
Don't get confused, okay? So that is sublimation. Yeah, now what are we talking about? Evaporation. So when a liquid is converted into the gaseous phase below its boiling point. Okay, so that is very, very important. And we have also seen what are the factors which is affecting evaporation. Okay? Like we have seen seasons. So evaporation is more in which season? Summer. But what does it tell us about the temperature? Temperature.
High temperature.
High temperature. So we have seen high temperatures will help. Okay. So very high temperatures will help in evaporation. What else will help? What else is important? Less humidity. Yes. Okay. If humidity is very high, then obviously it will not help it.
That's surface area.
Okay, so next one is what? Surface area. Surface area. Should it have more surface area or less surface area? More or less?
Yes.
Suppose I have a saucer, small saucer and a big saucer. Where does the evaporation take place?
Less. The less one, because the area is less, so the after it, the
Greater the surface area, the greater is the evaporation. Remember what I told you, example of a towel? Okay, what did we say? Suppose we want to dry clothes. How do we dry clothes? We spread it out, isn't it? We just don't put the towel in one place, like we have to spread it out. So we are encouraging evaporation to take place by increasing the surface area. Have you made a mistake there?
more surface area as well.
More evaporation. Okay, so we are encouraging evaporation to take place by having more. Yes, and then the last part of it is about wind. So greater the wind which is blowing, obviously the greater will be the evaporation. So we have also seen that more the wind which is blowing, obviously surface evaporation is going. Yes. Now this is where I want to talk about something more important, and that is something which is known as latent heat. This part of it is okay to you or not more or less understood? Yes, that is what we are going to be talking about. Okay? Now I want you to look at, if you are having the textbook, I want you to look at page number 7. Okay, on page number 7, we are talking about a change which is going to be talking, let us say a solid is getting converted into a liquid phase, and a liquid phase is once again getting converted into a gaseous phase. So let us look at the first part of it. How does a solid get converted into a liquid phase? You are basically heating it up. So when you are heating it, what is happening to the molecules?
Expanding.
Okay. The force of attraction, intermolecular force of attraction decreases, and the intermolecular space increases.
So we are now talking about these molecules which are held very close to each other, and it is in a solid phase. That means it's very strongly held. So when you are heating it up, what can you tell in terms of kinetic energy?
The molecule.
Yes, the kinetic energy of these molecules will keep on increasing. Okay, so it is capable of overcoming these bonds which is holding it. Correct? Kinetic energy is more, so it is overcoming the strong forces of attraction. So what is happening here? In a solid phase, these molecules are all very close to each other. But when you're heating it up, you know that these molecules are drifting apart, right? Because those bonds are getting weaker and weaker. That means to say, when you're heating it up, when you're heating a solid and it is getting converted into a liquid phase, what is happening is these bonds are getting broken up, and therefore there's going to be an increase in the kinetic energy. Okay, now my next question. Which has got more kinetic energy? A liquid phase has more kinetic energy or a solid phase has more?
Liquid.
liquid because it is moving. These molecules are moving. Oh, so obviously it has got more kinetic energy. Okay, so we have got one simple example. Let us say we have got water in the form of ice, and obviously I'm talking about liquid water. Okay, at what temperature does the solid get converted into
100 Celsius.
100?
0. Acid boiling.
At its
Solid
melting
to
point.
liquid.
Zero.
Exactly, 0. At 0 degrees.
Boiling point is 0.
Boiling point is 100 degrees. Okay, so this is melting. Ice is, you have taken ice in a tray, you are keeping it out on the table. It is melting. So 0 degrees is what? 0 degrees is your melting point. Is that okay? Did you understand? Okay, so because it's melting. Okay, so the same process, if I'm going to do the reverse of this process, where the liquid is getting converted into solid, it's called a freezing point. Correct? You're taking water in a tray, you're keeping it inside the fridge, it freezes. So basically, melting point is the same as freezing point. Okay, so now let us talk about what is known as latent. Latent basically means it is hidden. Okay, so we are going to see what is happening here. You have taken solid ice, okay, in a teacup, and then you are going to slowly heat it. I've already spoken about it. Suppose you have taken ice pieces in a beaker and then you are heating it. If you keep your thermometer, this thermometer is going to register 0 degrees Celsius because that is the that is what is the temperature of ice. Now, when you are heating it, we will find that there is going to be an increase in the temperature. Initially, what is happening? You find that this ice pieces are slowly melting. So we have a little bit of water is also there, and ice pieces are still floating in water. It's becoming smaller and smaller. But okay, what is happening here? The temperature does not rise. There is no change in the temperature. So what is happening? Where is this heat going? Okay, so that is basically what we call as latent. That means it's getting hidden up. Okay, Virat, come on, tell me, what do you know? What happens? Why doesn't the temperature increase? Why does it remain at 0 degrees? I'm heating it up. Okay, you are seeing that the ice is also melting. Okay, water is also formed. But till the entire ice has totally, converted into liquid phase, the temperature does not rise. Yes, Abhishek, come on.
And because the heat is used up by the molecules to break, to be break down or separating it.
Yes. Okay. So when you're supplying heat here, what is happening? Ice is in a solid phase. Correct? It is in a solid phase. That means there are very strong forces of attraction. So when you are supplying heat, this energy is basically used to break these bonds. So the heat or the temperature, you will not find that there is a temperature rise. Okay? And that is why this is what is known as latent heat of fusion. What is it called? Latent heat. Okay, this is heat of fusion.
So, ma'am, basically the molecules are using that heat as energy to separate.
Exactly. When the kinetic energy is increasing, this kinetic energy basically helps to break these bonds.
Process of changing liquid.
No, not the process. Now we are talking about what is latent heat of fusion. So what is latent heat of fusion? It is the heat which is required to break the bonds in a solid state such that it can overcome the forces of attraction. Okay, these are the forces of attraction. Okay, so it has to be more than the forces of attraction. So it is overcoming the forces of attraction. That is why you will not find that there is an increase in temperature. Okay, when will it start increasing?
After the ice is
Completely
melted.
melted. Yes, completely ice has got converted into water. Once the solid ice has got converted into water, and if I'm heating it up, then definitely it will increase by 10, 15, 20, okay, till it reaches what temperature? 100 degrees. So at 100 degrees, once again, there is another process which is going to start taking place. What is the process? Yes, the liquid is getting converted into gaseous. That is, it is a vapor state. Here again, water is boiling. What is the boiling point? It's 100 degrees Celsius. Okay, so it is boiling at 100, right? And if we have a closed container, for example, if I'm having a container which is closed and I'm having liquid water and I have a thermometer here, this is going to register 100 degrees Celsius, and when I'm heating it up, till when will it keep on increasing? When does it remain steady?
This is when all of the water is evaporated.
Correct. So till the entire water has got converted into gaseous state, or it has got converted into a vapor state. Abhishek, is that clear? Have you written it down correctly? So at 100 degrees, there is a change of phase. What is phase? What is phase? Phase is, we are talking in terms of solid, liquid, gases, all of them are phases. Okay, there's a change of phase. So when there's a change of phase, now here what is the change of phase? Liquid is getting converted into a gas. Okay, here again, what is the temperature? What will be the temperature here? When there is a change at 100 degrees. So there won't be any increase of temperature till the entire water has got converted into a vapor state. So what is it happening? Where is the heat going? It is hidden. So once again we call it as latent heat of vaporization. Not latent. So, okay, so here again we call it as latent heat of vaporization.
But the definition is same, right? Like even in water, when it's boiling, the water molecules are also again taking that heat and energy and separating.
And separating much further. What is happening in the gaseous state? Now this is the solid state when these molecules are held very close to each other. This is the liquid state where they have separated out little bit so that they can be fluid. When you heat it up further, what happens in the gaseous state? These molecules are moving really far apart. So technically, yes, the amount of energy that you are supplying here, what is happening? It is overcoming the forces of attraction, and therefore liquid phase is becoming the gaseous phase.
So in both latent heat and vaporization, both are taking the heat as an
To
energy.
bring about a change of phase. There is a change of phase here for latent heat of vaporization, for latent heat of fusion. Here again there is a change of phase when it is from a liquid state to a gaseous phase. Therefore it is called as latent heat of vaporization. Okay. In your notebook, take the these two. Have I dictated latent heat of vaporization? No, I have not. Vaporization I have given it, latent heat of vaporization. Come on, write down. Okay. Latent heat of fusion. Okay. Is the amount of heat energy, latent heat of fusion is the amount of heat energy required to change 1 kilo of solid, 1 kg, 1 kilo of solid into liquid at its melting point. At its melting point. Okay. Now here, the example that we are talking about is which material? Which material have we taken here?
Ice.
We have taken ice into water, water into steam. So basically, we are talking about water, which is your chemical nature. Okay. This is true for anything. Suppose you take solid or let us say iron. When you heat it up at very high temperatures, it becomes liquid, molten iron. Okay, when you heat it up much further, once again it turns into a gaseous. Is that okay? Did you understand? Okay. Now write down one more thing. Leave a line and write down latent heat of vaporization. And a similar one. Latent heat of vaporization is the heat energy required to change.
Is good.
Is the heat energy required to change.
On latent heat of vaporization.
Is the heat energy required to change 1 kg of what?
Is
Liquid.
heat energy
Required to, one second, what is it? Latent heat of vaporization is the heat energy.
The amount of heat energy.
Wait. Don't come. Okay. This is heat energy required to change. What are we changing? 1 kg of liquid.
I mean, could be 1 heat.
This is not liter, it is 1 kg. We are specifying the mass. 1 kg of liquid to gas. If you write down directly and we say promptly people write that down. Directly written at atmospheric pressure. Have you written that? At atmospheric pressure. This is atmospheric pressure.
So that's why.
At its what? Pressure. At atmospheric pressure at boiling point. So you have two statements you have there. See here. One of you please look. These are the 2 points which are given in the textbook.
Now I was atmospheric pressure.
See, whenever we are having the gaseous states, it all depends whether it is under pressure or whether it is an open container. Suppose I have a closed container like this, the pressure will build up. What happens in a pressure cooker? We have closed the lid. Okay, and we are heating it up. So what happens is it is a pressurized chamber. Suppose I keep it open, that means this is 1 atmosphere. That is the pressure which is felt on any body which is at sea level.
and the atmospheric pressure is very high.
This is 1 atmosphere. We are basically talking in terms of 1 atmosphere. That is the amount of pressure that you feel from the air, which is like about in 1 square meter.
So how do we feel that?
No, we don't feel it obviously because of the blood pressure. Body is also having blood pressure, so this is counteracting the atmospheric pressure. Okay. So have you written down the correct statement? Now you read your statement and tell me what have you written?
Latent heat of vaporization is the amount of heat energy to change 1 kg of liquid to gas at atmospheric pressure at its boiling point.
Correct. At its boiling point. So since we are talking in terms of water, obviously boiling point is going to be 100. But if we take any other substance, if we take ethyl alcohol or oil or kerosene or something, it will not be that. It could be something else. Have you followed till here? It is okay? Okay. Now, in case you don't have your textbook, please remember to mark out these 2 points. Those 2 points are your definition. Right? You have your volume. Volume also has this. So I want you to look at page number 7 once again. We are going to discuss. We read out this part so that you are clear about latent heat of vaporization and latent heat of yes. We have already yes this part. Okay, so Ari, you have it. Please. See from here the melting point. Read this.
The melting point of a solid is an indication of the state of the force of attraction between its body.
So you get the book.
The melting point of ice is 273.15.
So how much is 173 K?
0 Celsius.
How much?
0.
0.
0.
273 K minus 273 is how much? How will you change? How will you remember how to change degrees Celsius into K
Adding 273.
if you want to change? Yes.
Into minus.
Otherwise, you have to subtract. You remember that?
Yes.
Now we
Suppose
need to subtract, right?
if you have 10 degrees Celsius and I want to convert it into K, what will you do? Add. So you will add up to 73. Okay? Suppose I have given you a temperature in K, Kelvin, and I want to convert it into Celsius. So subtract it. Okay. So 273 K is how many degrees Celsius? 0 degrees. So instead of saying it is 0, we can ask. Mentioned. Okay, come on.
The process of melting that is change of solid state into liquid state. It is also known as fusion. When a solid melts, its temperature remains the same. So where does the heat energy go? You must have observed during the experiment of melting that the temperature of system does not change after the melting point is reached.
Okay, you should remember, all of you please go back home once again and in your textbook underline the important points. What is the important point here? When the process of melting is taking place, there won't be any rise of temperature. You get it? Yes.
Till all the ice melts. This happens even though we continue to heat the beaker. That is, we continue to supply heat. This heat get used up in changing the state by overcoming the forces of attraction between the particles. As this heat
What is this heat energy doing?
Breaking the particles.
Overcoming the forces of attraction or breaking the particles. Particles are still there.
But then it's kind of.
What is it? Force of
It's a molecular
attraction.
force of attraction.
Yes, it is overcoming the forces of attraction. See, if I'm using a wrong word, then sentence here. Breaking the molecule, no, it is not breaking this molecule. It is overcoming the force of attraction. Is that okay? Come on.
As this heat energy is absorbed by the ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the
What is the meaning of the word latent?
hidden.
Hidden. So that is why we are saying latent heat of fusion and latent heat of vaporization.
Hidden into the contents of the beaker and is known as the latent heat. The word latent means hidden. The amount of heat energy that is required to change 1 kilogram of solid into liquid at atmospheric pressure at its melting point is also known as the latent heat of fusion.
Okay? Latent heat of fusion. What does it mean? Is it from solid to liquid? Or is it from liquid to
Solid to liquid.
Solid to liquid at atmospheric.
Yes.
So particles in water at 0 degree have more energy as compared to particles
It's a latent heat of fusion, so atmospheric.
as compared to particles in ice at the same temperature.
Okay, 1 minute. So we are talking about solid getting converted into liquid. Okay? Ice, I'm talking about ice. Here I'm talking about water. Both of them are at 0 degrees Celsius. Okay? Which has got more energy?
Ice.
Sure? Why did you say ice? Ice has already got converted into water. So what has ice done? It has taken in so much of energy. It has taken energy to be converted into water, isn't it? So obviously water, because it is in a fluid state, it has got more kinetic energy. Do you understand? Suppose I have got, let's say, in summer months and all that, you feel like having lassi. Okay? I've got a lassi, but I feel it is very warm. Will I put ice cubes or will I put ice water? Ice cubes causes more cooling instead of water at 0 degrees Celsius. Both of them are at 0 degrees Celsius, but this has already absorbed so much of heat. It has got so much of energy. So this basically causes more what? Cooling process. Did you see that last sentence? Read that sentence again.
So particles in water at 0 degree have more energy as
Do you
compared
see
to the
that?
particles.
Particles at 0 degree water has got more energy as compared to ice, which is at 0. If you get it underline those important points. Happy? You have to do. Oh, okay, continue.
When we supply heat,
When we supply heat energy to water particles start moving even faster at a certain temperature. The point is reached when the particles have enough energy to break free from the forces of attraction of each other. At this temperature, the liquid started changing into gas. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point.
What is boiling point? What is your definition?
The temperature
Okay.
at which a liquid starts boiling.
Yes. At atmospheric pressure. When liquid starts converting into a gaseous phase at atmospheric pressure, that is known as your boiling point.
Particles from the bulk of the liquid gain enough energy to change into the vapor shape.
Yes, Mr. Which line has it?
Atmospheric is known as its. For water, this temperature is 373 K.
Okay, now how will you convert 373 K into Celsius? Right. Any temperature which is given in K, you have to convert it into C. You have to subtract 270.
Can you define the latent heat of vaporization? Do it in the same way as we have defined the latent heat of fusion. Particles in steam, that is water vapor at 373 K, 100 degrees Celsius, have more energy than water at the same temperature. This is because particles in steam have absorbed extra energy in the form of latent heat of vaporization.
Okay.
So-
Now let's see here. Once again, look at this part of it, the second part of it, where we are talking about liquid, and I'm heating it up, and it has turned into a gaseous phase. Okay, at 100 degrees. Suppose I have water at 100 degrees Celsius, and I have got steam at 100 degrees Celsius, which has more energy.
Water.
water. No,
Steam, because of its atmosphere.
No, ma'am, water would only have more energy.
Read the class sentence. You are not paying attention when you are reading.
This is because particles
Yes.
in steam have absorbed extra energy in the
Steam
form
has absorbed extra energy. How did it
form
get
of
converted?
latent heat.
So liquid water has got converted into vapor. Okay, that is steam. How did it get converted? Because we are heating it up. Okay, so this is your latent heat of evaporation. Okay, vaporization. So when you are having latent heat of vaporization, it has taken in so much more, and that is how it has got converted into a gaseous form. Okay, so obviously gaseous form of water, which is steam, has got much more energy as when compared to liquid water. Okay, so that's why I remember I told you, suppose somebody is working in some industry or something of that sort. If hot water falls on your skin, you get burns. And if steam at 100 degrees is hot, you are exposed to that, it causes severe burns. Because steam has got much more energy because it has got a latent heat of vaporization, by which it has got converted from liquid. Are you clear about it? Are you clear? Okay. When we are saying from solid to liquid at 0 degrees, liquid will have more energy. Second thing is when you're talking about conversion of liquid to a gaseous phase at 100 degrees, steam will have more energy, more kinetic energy, because it has already taken the vaporization. Is that clear? Come on, give me
So we infer that the state of matter can be changed into another state by changing the temperature. We have learned that substances around us change state from solid to liquid and from liquid to gas on application of heat. But there are some that change directly from solid states to gaseous states and vice versa without changing into the liquid state.
So that part of it we have got to Okay, so what is that called?
Sublimation.
Sublimation. When a solid is directly getting converted into a gaseous phase. Can you give me any other example? What are the substances which directly change?
Ammonium.
Camphor,
Ammonium.
ammonium,
Chloride.
chloride,
Sulfur dioxide.
not sulfur,
Naphthalene balls.
camphor,
Naphthalene balls.
naphthalene balls. Okay, yeah. Okay. Agarbatti, you know what
Not
happens
ash.
is it also has leaves some ash. When you're burning, part of it is getting vaporized, but part of it is getting converted. So it's not actually a substance. It's a mixture of many substances. So if you're talking about a pure substance, we can take camphor, we can take ammonium chloride, naphthalene. Okay, naphthalene also. Is that okay? Come on now, I'll give you two more definitions. Write up 2 more definitions. Put a star. Put a star and write down water vapor at 100 degrees has more energy than water at the same temperature. At which temperature? At the same temperature means what? Same. Because particles of steam. Okay. Because particles in steam
Particles in steam.
Absorb extra energy
absorb
due to latent heat.
extra energy in the form of latent heat of
Vaporization.
in the form of latent heat of vaporization. VAPO UR Is that okay? Yes? Put another star. These are 2 important points that you have to remember. Particles in water. Particles in water. Or in other words, you can write water molecules also. This one. Yeah, particles in water at 0 degrees Celsius. At 0 degrees Celsius. In bracket, you write down in K. How much is 0 degrees Celsius?
0 to 30 Kelvin.
Yes, that is 273 K.
Yeah.
Okay, has more energy as compared to the particles in ice as when compared to particles in ice at the same temperature. Why is the reason? What is the reason?
Because
It has absorbed
more energy.
in the form of
Latent heat of fusion.
that you have to write. Same thing, come on, write down. Similar type of a statement. Because, come on. This is because the molecules in liquid state has absorbed. Show me your molecule. You see the definitions. Molecules in the liquid state has absorbed extra energy
Process temperature. Absorption energy in the form of latent heat of vaporization.
has absorbed extra energy in the form of latent heat of fusion.
Fusion definition is not given.
Has to be. 100% both will be given. Extra energy in the form of latent heat of fusion. I want you to, now that we have done about latent heat of fusion and all, see this.
Yeah.
See this, all of you look at these questions which I give. Okay. See question number 7. Why is ice at 273 K more effective in cooling than water at the same temperature? You have just now seen.
Why rice?
I'm repeating the question once again. Okay. Why is ice at 273 K? What is that temperature?
0 degrees.
At 0 degrees is more effective in cooling
Because
as when compared to water at 0 degrees Celsius.
because the ice is melting into water. Right?
Part of it, can you tell? We are talking about solid ice 0 degree, water at 0 degree.
Because ice didn't absorb that much energy.
Ice is more efficient in cooling a substance as compared to water, as water has already absorbed a lot of latent heat during
Latent heat of?
latent heat of fusion during the conversion of ice into water.
Perfect. Do you understand? So for how you start, you can also start the other way around. If you want to write it in 2 sentences. For the conversion of ice into water, okay, energy has to be supplied. Which is what energy? Latent heat of fusion. Okay. So therefore, water which is at 0 degree has more energy as when compared to ice. Therefore, ice can cool efficiently. Is that okay? Did you understand? So it is the same thing as what we have written. So the statement has to be given. Latent heat of fusion has to be given. Okay. Now there is another question there. Question number 8. Abhishek, come on, 10.
What produces more and sweeter than boiling water or steam?
Boiling water or steam?
Steam.
Yes, on the same way. Then we know the answer correctly.
Okay, ma'am.
Ah.
Ma'am, during the process of latent heat of vaporization, steam absorbs more heat due in the form of latent heat of vaporization. So it causes severe burns than boiling water.
Terms of energy, which has more energy?
Steam.
Steam has got more energy as well compared to water. Right? How will you like to frame it? Same way. More or less it is the same. Yeah. Virat, can you tell me? Repeat the yes. Tell me.
The gaseous state of water is
You specifically talk in terms of steam. Because when you talk about
steam produces more severe burns as compared to the liquid state. As the steam is already absorbed a lot of heat during the conversion of liquid into gas.
in the form of
latent heat of evaporation.
So that part of it has to be high. Okay. So latent heat of vaporization is absorbed to bring about a change of phase. What are we converting from a liquid phase to a gaseous phase? And therefore, obviously, this causes more severe burns. Is that okay? Today, come on. For homework, I want you to do these 2 questions. Come on, write it down. Homework. Question number 7 and question number 8. The rest of the
One page number.
page number 12, that is the exercise.
Should we do the rest of them?
Yes, because we have already done all this. Each one of them we have already completed. Convert the following temperatures into Celsius heat. 300 K. Come on, do it now. First one, first exercise. 300 K
300.
I'm 293 K.
converted into
I'm 293.
It's 293.
mine is an old one. Was it there in your textbook? Okay, do that.
I'm 293.
Okay, mine is an old one, so they have given us that.
I end up 272.
20. Okay.
K or C?
C.
Ah,
Celsius.
minus 270. How much is that? This, you do the minus, subtracting
20 degrees.
20. That is 20, no? Ah, that is 20. What is it? C. 20 degrees Celsius. What is the next number in your text?
470. 470 Kelvin.
470. In my textbook, they are given as 570. So that, yeah, the numbers they have changed.
I also got it.
It's okay, any number that they give you, you can change it, so what?
197.
Oh, 197.
470. 470 minus 270. 270. 07. 7. Yeah, 7. 9. That is C. Okay. Then
Ma'am, next one.
Next one.
298.
whatever is given, C in my
25.
text. 25 they are given? Yeah, come on. 25. Next question. Convert 25 degrees Celsius. Convert it into K. What will you do? Twenty-five
298.
plus 270.
Ma'am, next one, 646. 646, 646.
No, first of all, you have to give him the temperatures. The temperature is 373 C. Convert it into K. Next question.
646.
We didn't have a next question. Visible vertical addition is better because you know your units and hundred spaces and 10 spaces you don't mess up. Now, the second question is convert
646.
298.
373 convert it into Kelvin.
100. 649. 100. तूने minus किया.
Convert it into C.
Oh, C. 100.
Sorry, it is given in C, convert it into K.
अब तो तूने minus किया.
Plus.
अच्छा.
This is C. Remember, K will always be more as when compared to the temperature in C.
646. 6.
Yes, ma'am.
Is it? 649.
7 and 7. This is more carry. 6.
9 is 7.
That is K. Okay, now the next question, okay? Give reason. Naphthalene balls disappear with time without leaving any solid. Read the question.
Naphthalene was same.
To change the question.
Ball disappear with time without leaving any solid.
Tell me, why is it disappearing? You're taking naphthalene balls, you're keeping it inside the cupboard. After 6 months, it's not there. Where does it go?
The process of changing solid to gaseous state
Without?
without boiling.
Okay, come on, write down. Write down the answer. Naphthalene balls.
Ma'am,
Never mind, we have time now. We are winding up the chapter now.
no, because I need to copy this in my.
You do one thing. I didn't want you to do. Write it here, take out this page and stick it up. So what we don't have.
Ma'am, my dad will put it very short as compared to this.
That's your identity. You write it behind this note. You write it behind this. Or if you have, don't be so lazy, I think you can write it again, isn't it? Come on, write down. Naphthalene balls disappear with time. Naphthalene balls disappear with time. So basically, you have to write the definition for sublimation. Come on, write down. Sublimation. Sublimation is the change. Sublimation, come on, look at it. What is sublimation?
Sublimation is the
A
change
change
in
of
solid state turn to gaseous to blood any
Without needing, no, we can sometimes
Change of state.
without going through a liquid phase. That is important. Come on, write down. It's a process of change of state
Directly from
solid to gas without changing into a liquid phase. What is the spelling for phase?
PHA.
Don't write FACE. Okay?
I wrote mine like different answer.
Okay. But the definition for sublimation should be there.
The sublimation is the change of state
Naphthalene
directly
ball disappear with time as the process of sublimation takes place, which is the change of solid directly into gaseous state without changing into liquids.
Done. Have you written? Is that okay? Now I'm asking you a question. Okay? We are talking about a change from a solid directly to a gaseous phase. Is this also
yes from
possible?
condensation. Right.
No ma'am, decomposition. As per new decomposition, in the
What
old
is your
one,
answer?
Decomposition.
He's given one answer.
Decomposition. Decomposition.
What's your answer? What is this process called? What? What's your answer? Did you see this solid to gaseous phase? Was it, what is it called? Sublimation. When a gaseous phase, that means you're coloring. This is sublimation.
I'm in the old,
See here. A change without or vice versa.
I'm but then,
That
ma'am,
means you're condensing. So what do we say? When the vapors of ammonium chloride are condensed, it does not go into the liquid phase. It directly goes into the solid phase.
ma'am, this like first it was called sublimation, now it is called as decomposition.
Decomposition is not there. Decomposition reactions are different. For example, you take calcium carbonate and you heat it up. It decomposes to give you calcium oxide and carbon dioxide. That is
My teacher told
decomposition.
us, chemistry.
No, I think you are getting confused. She must have told that's cancer. You must have thought so.
No ma'am, she told about the same place.
It's not decomposition.
Can you give me one example of gas to
A gas which is, now for example here,
So let's say
See
change
here.
from
Ammonium chloride,
condensation.
see this, you see this experiment, okay, so what have we taken away? We are having ammonium chloride, we are heating it up, it is directly going into a gaseous phase. You can see the fumes of ammonium chloride. You stop heating, that means the temperature cools down. And afterwards, after some time when it is cool, you take out the funnel, inside the funnel you find that it is all ammonium chloride, which is condensed. It is directly connected, there is no liquid phase at all. Okay? Iodine is also another substance. Iodine is solid, when you heat it up, directly goes into iodine, which is a gaseous phase. Collect the gases, cool down, once again it comes back into the substance. Did you get it? Fine.
Pressure is the
We have already done any of these things we have already done. Okay, we can get the smell of perfume sitting several meters away. We have written it. Virat, you would like to say this? We can smell the perfume even when we are sitting in the next room. Why does it happen?
Why does the palm
No, it's not that. It's a problem. Okay, suppose somebody is making nice, mommy is making nice food in the kitchen, you can smell it. Why? Okay, we are talking now about solid, liquid, gaseous states. We said air, so you have identified what is happening. How are these molecules in air?
The molecules are traveling through air.
Okay, gaseous state, what is happening? Are they having strong bonds? No, okay. Then,
Ma'am, ma'am, can I first say on the start? We can get the smell of the perfume sitting several meters away because the particles of the perfume get mixed into the air, and
That one, yeah.
high to the atmosphere and the kinetic energy. By its kinetic energy, it travels to us like this.
okay, what about you? I want you to talk in terms of bonds. Are these molecules held strongly in a gaseous state? Tell
And
me
due
that
to,
point.
ma'am, due to the molecules of the gases are held weakly and their intermolecular force of attraction is also weak, the
Molecules are there.
molecules of the perfume travel straight into the atmosphere.
Is that okay? So we need to talk in terms of forces of attraction. These molecules are held very weakly, forces of attraction are very less, and that's how these molecules are. Is that okay? So whenever we talk in terms of solid, liquid or gases, two things are important to learn. One is how strongly they are held in the solid phase. In the liquid phase, it's a little, and whereas in the last one, that is the gaseous phase, there is hardly any forces of attraction. So when you write your answers, you're going to be writing with this. Is that okay? Are you ready for the test now?
Yes,
Yes.
ma'am.
Test will come up next week itself, maybe this Sunday. Are
I'm
you ready?
not.
This one is max and SST.
It's a
What all do you have?
Max and SST.
These are just over practice related to
You have back to back.
Max and SST.
Okay. Okay.
Go on
Okay.
in.
History afterwards.
And 80.
And now in science. Are you thorough with the chapter?
80.
Because next class, next Wednesday, we start with another chapter, which is this matter around the sphere.
What will we do now then?
First chapter. Next chapter. Read it properly, okay, Nisha?
Our teacher has released second chapter.
You have already started. And from next time, all of you please get your textbook. Already started the second chapter. Is over. It's over also. So you must be thorough with your second chapter, no, Nisha? Yeah? Okay, thank you, children.
Then after match
मैंने नहीं आया मैंने वो वाला
आया।